All right, today we're going to cover the bilge pump system on a vessel. So initially we want to make sure that we have a proper PPE. We want to come over to the bilge pump system, and we're going to take a general look at the condition of the pump. Look at the condition, looking for hazards, the electrical cable, make sure that that's all intact, no frayed wires, the pump and the piping system, that they appear to be in good condition, no leaks. You definitely don't want any water actively leaking on an electrical pump. So every vessel is required a different number of pumps on board, and they may require different throughputs. So you got to know what vessel you're on, what the applicability is for that. There are also different piping size requirements. So you need to ensure that you check the number of pumps that are required, the throughput that it's required to put out, and the different piping requirements. So the bilge pump is designed to draw suction from each watertight compartment. Each watertight compartment has its own pipe that connects to a manifold. Each pipe has its own individual closing valve, stop valve. So the control valves are located here on this manifold, and they're all identified here in writing so that you know exactly what suction point you're drawing from. So typically the way we run this test to ensure that the suction lines are clear is we'll ask the vessel's master to actually pump some water into the forepeak, and we'll open the valve in the forepeak. We'll start the bilge pump, and we'll draw suction from the forepeak overboard so we can see that the line's actually clear, the manifold's cleared, and it's actually able to operate as designed. So something to be aware of is that your bilge pump can actually serve as a secondary fire pump. In that case, such as on this vessel, you have a fire pump that's tied into a manifold, but it's also tied into a C-suction strainer. What you want to ensure is that when we're looking at the bilge system, that the valve is secured and securable from the C-suction, so that we're drawing, when we're going to operate the bilge system, we are going to draw water from the manifold and the specific watertight compartment that we want to dewater. If you look here, this bilge pump serves as an additional fire pump that can, if you open this valve, you open this seawater suction valve, and you secure the manifold here, can draw water from the sea and provide firefighting water. And that goes down to this system. So what we want to ensure is when we're testing this as a bilge water system, that this valve is secure, the seawater valve is secured, the manifold is open, and that we're drawing water, like I said, from the forepeak. Then we have the overboard discharge valve open here. We'll follow the piping down, and we'll look at the overboard discharge valve. We've got the pipe coming down this way, the overboard discharge. As you can see on this vessel, this can also tie into and provide water from the sea to their ballast system. They have this all color-coded, so the blue piping is for their ballast water system. We want to ensure this valve is closed. They keep their valve handle right here, so it's closed. So we're continuing on with the overboard discharge, and they have their overboard discharge valve right here, and you can see the overboard discharge at the bulkhead there. Another very important part of the bilge system is some vessels are required to have an emergency bilge suction. So you want to go around the vessel and ensure that you find it. Here's the emergency bilge suction valve for this vessel in particular, and you want to ensure that that you actually have this separate from the manifold. Two more items that we want to look for in the engine room compartment. We want to look for a discharge of oil prohibited placard. Ensure that there's one somewhere in here along the piping. Typically it's like by the overboard discharge or the motor controller that operates or energizes the bilge pump. Another thing that we need to talk about is when required, they got to have bilge alarms. So Typically in the engine room, you're going to have a float switch type bilge alarm that's activated when the level of water rises in the space or in the bilge, and it gets to the float switch, raising the float switch, and then activating the alarm up in the wheelhouse. So you can do a real life test, maybe get a bucket of water and slip it under, if feasible, to have the float switch conduct a real life trial that it actually works. One last thing, smaller vessels aren't required to have a fixed bilge pump, and they may have a portable bilge pump. So when checking the portable bilge pump, you need to ensure that it does provide the adequate discharge capacity and that they have a long enough hose to reach outside the vessel to properly discharge the water overboard. All right, in closing, to complete the inspection of the bilge system, we identified hazards. We looked at the cautions to take and the proper PPE that we wore. Looked at the pumping capabilities, we looked at the piping arrangements, looked at the manifold, the installation of non-return valves, the size piping location, the strainers, suction points, the independent and emergency suction capabilities, the number of pumps that are required, the location, the operation of pumps, capabilities of other pumps. We looked at the pollution placard placement, the operation and labeling of remotely operated valve controls on the manifold, the operation of bilge alarms and how to test them, and portable pumps. We talked about portable pumps and how to verify that they're adequate. And if you have any questions on any of the items that we covered or that we didn't cover, make sure you write them down and get with your verifying officer.